So this is just the original, I think, 3 tasks for 1.2. So essentially we're just basically iterating through the sum and adding, the number in the loop to the sum every time. We're just doing it with a for loop, and then the equivalent code with the while loop, and then the equivalent code with a do while loop. So this one's probably a good one to use step debugging for. So at the start, the user will be prompted to add a number for the upper bound, how many times we're going to be iterating. So let's just make it small, easy to work with. We'll just do 4 iterations. Enter that. And let's have a look at the code. So basically, for the for loop, for loop's basically something where you essentially know in advance sort of when it's going to stop. It's quite good for when you kind of know how many iterations you want to do. Yeah, so it's not guaranteed to always run. I mean, it will only run so long as this condition's true. Yes, I've slightly modified this too, so then I'm not assigning the variable at the start every time, because we want to do this with multiple different types of loops. So I'm just, I'm giving it a number, but I'm not declaring it. So let's just run through. One, 2, 3. So it did 3 iterations, and that's because I started the number off at 1. So yes. So 1. It already starts off 2, 3, 4. So it's only going to do 3 loops for each one. We'll get our return. It did 4 loops, my mistake. So there's the average there. We'll continue. What did I miss? Alright. The while loop, so it's not always guaranteed to run either. I guess the while loop's kind of good if you don't really know how many iterations you have in advance. I guess in this situation we can figure it out, but yeah, generally you use a for loop when you know how many iterations you got planned, and a while loop when you don't. So we'll just step through it. So we should get 4 of these as well. Same result. Step 3 for the do while loop. So do while loop is like the while loop, where you don't know how many iterations you're going to have in total, but the difference is the do loop will always iterate at least once, because you can tell that the condition happens after the first iteration. So this is good when you don't know how many iterations you are going to have, but you have to have at least 1 iteration or more. Should happen 4 times still though. And yes, same result for all of them. So those are basically the 3 main loop types, why you want to use them, and how to make equivalents of them. I'm just just going to be reading through these ones here, and I'm going to, I guess, sort of guess what problems we have with these or what the output is, and we're going to actually check in Visual Studio. So for the first one, I believe that we'll be stuck in this while loop because we haven't used any curly brackets to encapsulate this section. So C is never actually going to increase, and product's just going to keep being times by 5. So we'll check that now. I've already written these ones out so we can check more quickly. What do we got? Right. Ah yes, I should put this here. Oh well, it's already shown that this is why it's not happening. It's just continuously looping. We can't fit 2 lines in here. If you wanted it to do what's probably intended, there we are. And products also, you know, anything times 0 is going to be 0, so that's not going to be increasing. Alright, next one. What do we got here? Alright, so I can already see here that we're going to be stuck in this while loop forever. And the reason is that A is a negative number, whereas 2 starts off at 0. Sorry, I mean B starts off at 0, but is increased by 2 every time, which is always going to be even. So it's A is always going to be not equal to B. So we're going to be stuck in this while loop till the end of time. Let's just have a look. What's this? Ah, I made an error here. What do we got? Yep, we're never going to leave it. So I guess one solution. There we are. Alright, now this one, what do we got here? X equals 1, and total x less than or equal to 10. So, I don't think there's going to be any problems with this one. I mean, so while ever x is less than or equal to 10, It starts at 1 and it goes up by 1 every time. I think this one's going to be fine. Let's test. Wait, what was that? Ah, yes, yes. You can't total plus, sorry, total equaling total, which is unassigned, so it's not possible to do it this way. You've got to assign it a value first. So we'll try giving it 0. Start. Ah, yes, and I should probably add a console.write line. Try now. Yep, so that's all good now. Yeah, so the error here was that total hadn't been assigned yet. It was saying total equals total plus x, which, you know, was kind of undefined at that time. Alrighty. Well, I'll try this one. Y is less than 10. Okay, straight off the bat, the problem here is that y is assigned within the while loop. Y doesn't exist before it. We should be going to get an error up here, and also the fact that y is being set to 0 every time, it can't increase. I mean, it will increase, but then at the start of this loop it will just be set back to 0 again, so we're going to be stuck forever. So this needs to be outside of the while loop. We'll do that now. Try it now. And it's fine now. Okay. Next. Let's go and show this recording. Yep. Alright. Alright. So Z's lowercase here. Here it's uppercase. Wait, is it? No, sorry. Sorry, my mistake. So what's the problem? We're going to be stuck in this while loop forever because this is sort of going in the wrong direction. Z starts off at 0. No, it's never going to actually run. Because Z starts off at 0, it's only going to run while Z is above 0, which it never is. Never will be. And because it's a while loop, it's not a do while loop, it's never going to run at all. Let's try. Yep. So what we need to do is, I don't know, let's make it 10. Try now. Z equals Z minus 1. Ah, my bad. Set it to 10 up here. Okay, now it's doing what we'd expect it to. Next. Okay, these should be, I think they're called semicolons, not, you got the wrong symbol here. So I think this is going to error. Yeah, straight off the bat. Alright, let's try now. Yeah, so we got 99 hellos, I'm pretty sure it would have been. Alright, so that's so good now. Next one. Ah, yes, this is the one where I is in caps here, but everywhere else it's lowercase. So it's going to see this as a variable that hasn't been declared. It's not defined. It's not anything. We need to change this to a lowercase I. And then I'm pretty sure we'll be in luck. No. It still won't work because I is starting at 1 and it's going to keep going whenever I is greater than 10. Well, it will stop as soon as it starts. Let's see. I'll fix this error so we can actually run it first. I think that's just a copy paste error there. Let's try now. Yep, never ran in the first place. I guess, see if we make it that I starts off greater than 10. It's never going to stop though. So I think what we're going to have to do here is this. Yep. So it should have printed it out, I think 8 times, because it's only printing it out if it's actually greater than 2. Okay, so that's pretty much the end of that one. So this one's pretty simple, just this task here. Change these while loops into for loops. So I've got the original code from the PDF here, just added this so we can actually read it. This is the for loop equivalent of the first one. Same deal with the second one from the PDF, and then the for loop equivalent. So yeah, there's not a whole lot to say about this one. It's pretty straightforward. The only trick was you got 2 variables really at work here, so just these commas for the increments and the assignments of those variables. So I'll just show the code works now. That's the first while loop, for loop equivalent, second while loop, second for loop equivalent. And yeah, there's really not much else to say about this one. So this is the number guessing game, which is actually kind of fun to make. So got two main variables. Yes, this is it. So this is the secret number. This is what player 1 enters, and it's what player 2 has to try and guess. Player 2's input will be, the number. So the rules are that, of course, has to be a number. We check for that here. Try to catch it. So if we get a format exception from the player's input, say they don't enter a number, or they enter like a decimal place or something, so we'll get a format exception. It'll send the player a warning, and they'll have to continue, shoot them back up to the top of the while loop, where they'll be asked to enter the number again. It has to be between 1 and 10, so it's outside of that range. If it's too high, they'll get this. It'll shoot them back to the top of the loop. If it's too low, they'll get this, shoot them back to the top of the loop. Otherwise, it's valid. So, then it's assigned at that point. And we break out of this while loop, because this is basically just checking for correct input from player 1. Then we go and check player 2's input. So this is essentially the same except for one thing for player 2. So they can enter something that is a number. It can be in range, but it has to be equal to the secret number. So if it's not equal to the secret number, they'll get a message telling them they're incorrect and to try again, and it will also go to the top of the loop. Whereas, if they do guess the secret number, we can break out of this loop, and they, at that point, they're successful. Probably should have wrote something extra, maybe. You win, push any key to exit, and then the player can just push any key, and the program will finish. So let's just loop through. So go to where the player actually has to enter something. Right, I'll enter a letter, for example. It'll catch it as it has, and then give them a warning, shoot them back to the top where they'll have to start again. So we're going to check for their input again. Here we are. Let's enter something too low. Negative number. So this time, try statement, doesn't catch any error, so it just jumps on. Is it too high? No, it's not too high, but is it too low? Well, yes it is. So they'll have to go back to the start again. We'll enter something too high, 100. Was it too high? Yes it was. Start again. Now let's enter something valid. 5. So this is going to be valid. We'll get down to here. It is valid. Break. We're out of this while loop now. So everything is pretty much the same for this while loop for player 2, except they have to get the same number. So let's do a number that's valid, but not the secret number. Have player 2 guess the number. Okay, so we add, what do we enter before 5? Let's add 7. Jump through, all valid, but not the secret number. So, give them a warning, make them try again. Alrighty, let's enter the right one. 5. They're going to win this time. We'll go through. None of these conditions are met, so it has to be right. Because these are all basically checking for either wrong number or wrong input. So, well done, congratulations. It's all done, you win. little victory message, and then push any key, enter, and the program is over. I'll just have to process that. Yep. So that's pretty much all there is to say about that one. So in this task, basically we want the user to be able to enter an upper bound. Based on that upper bound, we will iterate between all numbers up to that upper bound that are actually equally divisible by 4 but not equally divisible by 5. So the way we check that is this modulus operator will return any remainder of something divided by 4. So if there's no remainder, we know it's equally divisible. Whereas if it is, we use modulus by 5 and there is no remainder, we know it is equally divisible by 5. So we want this to be true and this to be true. Well, this is true if it's not if there's no remainder, it's going to be false. If there's no remainder, it's going to be true. So the way that this is met is if there's no remainder, true. If there is a remainder, true. If they're both true, write the number. And we just like in all the other tasks, we have this input validation. It's got to be a number, it's got to be within valid bounds. And if that's all met, we can break out of the while loop. So let's just give this one a test. We'll just step through. We won't enter a large upper bound because we don't want to be stuck in a huge loop. Going up to about 20 is probably a good idea. Please enter an upper bound. 21. So 21's valid, so it goes through. We'll just sort of iterate through this as quickly as we can. Alright, so we know it works because 4 is equally divisible by 4, but not by 5, 8 as well, 12 as well, 16 as well. We know that 20 is equally divisible by 4, but we also know that 20 is equally divisible by 5, so it was excluded. So we pretty much know how this. I don't think there's a lot more to say about this. I mean, the input validation's the same as everything else I've worked on, and I've already explained this. So yeah, that's pretty much the end of that one.